The NEC, which stands for National Electrical Code, does not forbid the use of appliances rated over 12 amps with a 15 amp plug. However, it mandates that the branch circuit wiring must be appropriately sized to handle the appliance's full load. For an air compressor or microwave oven, the branch circuit wiring must be sized for 15 amps. The allowance for products rated over 12 amps on a 15 amp plug, as permitted by underwriters' laboratories, or all, and accepted by inspectors, arises from their classification as non-continuous loads. A continuous load, according to the NEC, is defined as a load that operates for a duration of 3 hours or more. Since air compressors and microwave ovens are not typically operated for such extended periods, they are classified as non-continuous loads. The NEC provides allowances for utilizing overcurrent protection devices that are rated lower than the appliance's full load, contingent upon the appliance being classified as a non-continuous load. Therefore, an air compressor or a microwave oven can have an overcurrent protection device rated for 15 amps. The code does not mandate plugging appliances into receptacles rated for their full load. However, adhering to this practice enhances safety by ensuring the appliance receives adequate overcurrent protection. This explanation hinges on understanding key NEC sections and definitions related to branch circuits, overcurrent protection, and load types. Let's delve into these aspects for a clearer picture. Branch circuits are fundamental components of electrical systems. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. These circuits are responsible for delivering power to various points of use, such as lighting fixtures, receptacles, and appliances. Overcurrent protection is a critical safety feature in electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can lead to overheating, fire hazards, and equipment damage. These devices automatically interrupt the flow of electricity when the current exceeds a predetermined safe level. Understanding the distinction between continuous and non-continuous loads is essential for proper electrical system design and safety. As previously mentioned, a continuous load is defined as a load that operates for 3 hours or more at a time. In contrast, a non-continuous load operates for less than 3 hours. The NEC provides different requirements for sizing branch circuits and overcurrent protection devices based on whether the load is continuous or non-continuous. Section 210.20 of the NEC addresses overcurrent protection for branch circuit wiring. It allows for the consideration of continuous and non-continuous loads when determining the appropriate size of overcurrent protection devices. For non-continuous loads, the overcurrent protection device must be rated at not less than 100% of the non-continuous loads plus 100% of the continuous loads. For continuous loads, the overcurrent protection device must be rated at not less than 125% of the continuous loads plus 100% of the non-continuous loads. Section 210.23 of the NEC outlines the permissible loading of specific circuits based on the receptacle and branch circuit rating. This section does not explicitly consider continuous and non-continuous loads when multiple receptacles are connected to the branch circuit. Table 210.21 in the NEC provides information on the maximum loads permitted on branch circuits. For a 15 amp rated branch circuit, the maximum load permitted is typically 12 amps. This table also specifies the types of receptacles that are permitted on different branch circuit ratings. In order to reconcile these seemingly conflicting sections, it is important to understand the intent and application of each section. Section 210.20 focuses on protecting the branch circuit wiring from overcurrent, while Section 210.23 and Table 210.21 address the overall loading of the branch circuit and the types of receptacles that are permitted. The NEC permits appliances rated over 12 amps with a 15 amp plug for non-continuous loads. It's primarily because the appliance is not expected to draw its maximum current continuously for an extended period. This allows for some flexibility in appliance design and usage while still ensuring safety. UL listing and inspector acceptance are based on the understanding that these appliances are designed and tested to operate safely within the limitations of a 15 amp circuit when used as intended. However, it is crucial to follow the NEC guidelines for sizing branch circuit wiring and overcurrent protection devices to ensure that the electrical system can safely handle the appliance's load. In summary, the NEC allows for appliances rated over 12 amps with a 15 amp plug, provided that the branch circuit wiring is properly sized and the appliance is not a continuous load. UL listing and inspector acceptance are based on the understanding that these appliances are designed and tested to operate safely within the limitations of a 15 amp circuit when used as intended. The NEC is a comprehensive set of guidelines, and it's important to consult the specific sections and tables relevant to your situation for complete and accurate information. In real-world applications, several considerations come into play when dealing with appliances and electrical circuits. Firstly, proper wiring and installation are paramount. All electrical work should be performed by qualified electricians who are familiar with the NEC and local codes. Secondly, it is essential to understand the appliance's power requirements. Check the appliance's nameplate for its voltage, amperage, and wattage ratings. This information will help you determine the appropriate branch circuit size and overcurrent protection. Thirdly, avoid overloading circuits. Do not plug too many appliances into a single branch circuit, as this can lead to overheating and potentially dangerous situations. Use a circuit analyzer to check the current draw of appliances and ensure that the circuit is not overloaded. Fourthly, regularly inspect electrical cords and plugs. Damaged cords and plugs can pose a fire hazard. Replace any damaged cords or plugs immediately. Fifthly, use ground fault circuit interrupters, or GFCIs, in wet or damp locations. GFCIs are designed to protect against electrical shock and are required in areas such as bathrooms, kitchens, and outdoor locations. In addition to the NEC, other standards and regulations may apply to electrical installations. UL is a widely recognized safety certification organization that tests and lists electrical products. Products that bear the UL listing mark have been tested to meet specific safety standards. Local electrical codes may also impose additional requirements or restrictions on electrical installations. These codes are often based on the NEC but may include local amendments. Understanding these codes is crucial for ensuring compliance and safety. Let's consider a few examples to illustrate these concepts. Firstly, a homeowner wants to install a new window air conditioner. The air conditioner's nameplate indicates that it draws 12 amps. The homeowner should ensure that the branch circuit is rated for at least 15 amps and that the overcurrent protection device is also rated for 15 amps. Secondly, a commercial building has a microwave oven in the break room. The microwave oven is rated for 13 amps. The building owner should ensure that the branch circuit is rated for at least 15 amps and that the overcurrent protection device is also rated for 15 amps. Thirdly, an industrial facility has an air compressor that is used intermittently throughout the day. The air compressor is rated for 14 amps. The facility manager should ensure that the branch circuit is rated for at least 15 amps and that the overcurrent protection device is also rated for 15 amps. In each of these examples, the branch circuit wiring and overcurrent protection devices must be sized to handle the full load of the appliance, even though the appliance is not necessarily a continuous load. Additionally, the NEC provides guidance on the use of extension cords. Extension cords should only be used temporarily and should be rated for the amperage of the appliance being used. Avoid using multiple extension cords or daisy chaining extension cords together, as this can create a fire hazard. Surge protectors are also important for protecting sensitive electronic equipment from voltage spikes. Surge protectors should be used for computers, televisions, and other electronic devices. The NEC also addresses the installation of arc fault circuit interrupters, or FSIs. FSIs are designed to protect against electrical fires caused by arcing faults. FSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. In conclusion, understanding the NEC and its requirements is essential for ensuring the safety of electrical systems. By following the code and best practices, you can minimize the risk of electrical hazards and protect your property and loved ones. When dealing with electrical systems, always prioritize safety. If you are unsure about any aspect of electrical work, consult a qualified electrician. Remember to always turn off the power before working on any electrical circuits. Use appropriate personal protective equipment such as safety glasses and insulated gloves. Never work on electrical circuits in wet or damp conditions. Avoid touching exposed wires or terminals. If you experience any electrical shocks, seek medical attention immediately. By following these safety guidelines, you can minimize the risk of electrical accidents and injuries. The NEC is a living document that is updated regularly to reflect changes in technology and safety practices. It is important to stay up to date on the latest edition of the NEC to ensure that your electrical systems are compliant and safe. You can access the NEC through various sources, including the National Fire Protection Association or NFPA website and various online resources. Consider attending electrical safety training courses to enhance your knowledge and skills. Many organizations offer training courses on the NEC and electrical safety. These courses can provide valuable insights into the code and best practices for electrical work. Remember that electrical safety is everyone's responsibility. By being informed and taking appropriate precautions, you can help prevent electrical accidents and create a safer environment for yourself and others. In practical terms, let's further clarify how to apply these principles with specific voltage considerations. For a 120-volt circuit, the calculations remain consistent, ensuring the overcurrent protection and wiring are adequate for the connected load. However, in a 208-volt or 277-volt system, the amperage draw of the same appliance might be different, but the NEC principles for continuous and non-continuous loads still apply. In a 480-volt system, which is common in industrial settings, understanding the full load amps, or flow, of equipment is critical for proper circuit sizing and protection. Regardless of the voltage level, always consult the equipment's nameplate for accurate ratings and refer to the NEC tables for conductor ampacity and overcurrent protection requirement. For instance, NEC Table 310.15 provides guidance on allowable ampacities of insulated conductors. Remember, using the correct size and type of conductor is crucial for preventing overheating and potential fire hazards. Also, NEC Section 110.3 B requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means following the manufacturer's instructions for the appliance or equipment being installed. Furthermore, consider the impact of voltage drop on circuit performance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When sizing conductors, account for voltage drop to ensure that the equipment receives adequate voltage. In addition to these technical considerations, proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding in Article 250. In summary, the NEC principles for handling appliances rated over 12 amps with a 15 amp plug are applicable to various voltage systems. Understanding the concepts of continuous and non-continuous loads, proper circuit sizing, overcurrent protection, grounding, and bonding is crucial for ensuring electrical safety and compliance with the code. Always consult the NEC and qualified professionals for specific guidance on your electrical installations. Additionally, understanding the role of different types of receptacles is important. For example, a standard 15 amp receptacle is designed to accept plugs with a specific configuration. Using the wrong type of plug can damage the receptacle and create a safety hazard. The NEC specifies the types of receptacles that are permitted on different branch circuit ratings. Tamper-resistant receptacles are also required in certain locations, such as dwelling units, to protect children from electrical shock. These receptacles have internal shutters that prevent objects from being inserted into the slots unless both prongs of a plug are inserted simultaneously. Furthermore, consider the impact of harmonics on electrical systems. Harmonics are caused by nonlinear loads such as electronic devices and variable frequency drives, or VFDs. Harmonics can cause overheating of conductors and equipment, as well as interference with other electronic devices. The NEC recommends using harmonic filters to mitigate the effects of harmonics. Power quality is also an important consideration in electrical systems. Poor power quality can cause equipment to malfunction or operate inefficiently. Power quality problems can be caused by voltage sags, voltage swells, transients, and harmonics. The NEC recommends using power quality monitoring equipment to identify and address power quality problems. In addition to the NEC, other standards and regulations may apply to electrical installations. The Institute of Electrical and Electronics Engineers, or IEE, develops standards for electrical engineering. The American National Standards Institute, or ANSI, accredits organizations that develop standards. The Occupational Safety and Health Administration, or OSHA, enforces safety regulations in the workplace. Understanding these standards and regulations is crucial for ensuring compliance and safety. Furthermore, consider the importance of documentation in electrical systems. Proper documentation is essential for troubleshooting, maintenance, and future modifications. The electrical drawing should accurately depict the layout of the electrical system, including the location of conductors, equipment, and overcurrent protection devices. Equipment schedule should list the specifications of all electrical equipment. Test reports should document the results of electrical testing and inspections. In conclusion, understanding the NEC and related standards and regulations is essential for ensuring the safety and reliability of electrical systems. By following the code and best practices, you can minimize the risk of electrical hazards and protect your property and loved ones. Always prioritize safety and consult qualified professionals for assistance. Electrical systems are complex and require careful attention to detail. Taking the time to understand the principles of electrical safety can make a significant difference in protecting yourself and others from electrical hazards. Remember, electrical safety is not just a matter of compliance, it is a matter of life and death. By being vigilant and proactive, you can help prevent electrical accidents and create a safer environment for everyone. The concepts discussed here, while seemingly straightforward, often require a deep understanding of electrical theory and practical application. When in doubt, always seek the advice of a licensed electrician or electrical engineer. Their expertise can help ensure that your electrical installations are safe, compliant, and efficient. The NEC is not just a set of rules, it is a framework for ensuring the safe and reliable use of electricity. By embracing its principles and staying informed about the latest developments in electrical technology, you can contribute to a safer and more sustainable future. The information presented here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with qualified professionals for specific guidance on your electrical installations.